straightforward. What are the different groups that you see? Anyone? Amino group? Hydrogen? Side chain, okay, the R group side chain. And the carboxylic acid, which is why we call it the amino acid. Amino acid, so you have the amino group and the acid group. Okay, so there were a few questions here. Number one, the R, we have to write the side chain. Okay, so for this question, it just asks what are the groups. So typically, you saw in your first slide there are a lot of different groups for the side chains. So in this question here, we just put the different side chains as one generic R. Okay, so just for this question here as an R, if people ask you, what are the groups that surround the central carbon, you have an R, which is the side chain. We have many different kinds of side chains, which one is R. So you can write R or you can write R and side chains. Easy for you all. There was also another question on hydrogen, was it? Okay, so the question here, in the central, well, you see in the diagram there's a central carbon, right? Around the central carbon, you all learn in chemistry, maybe the carbon has four bonds, basically. So in the 4 bonds, here in this diagram you can see one bond with the amino group, one bond with the carboxylic acid group, one bond with the side chain, which we mentioned before, R, and another bond with the H. The H is hydrogen. Alright. Any other questions on this one so far? No? Okay, so we see that your typical amino acid has these 4 groups surrounding the central carbon, okay, or the alpha carbon. So that is part A. In part B, 3 of the groups will remain the same in typical amino acid. So like we said, amino acid, so we will have the amino group and the carboxylic acid group, which will remain the same. And you will see that the H also remains the same. The thing that varies is what group is there in your R side chain. Yes, so your side chain, the R will change. In your first slide of the notes, you see all the different versions of R. So you have different amino acids, so R group has different side chains, different arrangements, some slightly different atoms as well. So all these different things will give your individual amino acids their own different properties. Okay, like we said before, whether it's acidic, whether it's basic, whether it's hydrophilic, or whether it's hydrophobic. Alright, so that is the group that will change among your typical amino acids. So we talked about your amino acids and your typical structure of the amino acids. Well, there's some functions of proteins. You all will find that in the notes as well. So some of the things that we use proteins for, or that proteins are useful for in our bodies, like we said before, proteins, enzymes. Your enzymes are proteins. So enzymes are very important for carrying out the reactions in your body. Antibodies are also made of proteins. Your hair and your nails actually have proteins in them as well. Blood cells, you have structural proteins there. The brain, very important. Nerves, muscles. So all these cells and structures within your body all have proteins in them. So it's very important that we actually maintain protein levels within our bodies. And they can also act as cellular messengers and cellular construction workers. So in other words, these can form structures within your body. So these are sort of like your construction workers there. Any questions so far? No? Alright, let's go. Activity 2. Now, activity 2, we have plants and microorganisms. Like we said before, typically in the atmosphere you will find nitrogen N in the form of N2, which is atmospheric nitrogen. Now, atmospheric nitrogen is very inert in carry out nitrogen fixation. So in other words, can we convert N2 into nitrate or ammonia? We can't. We're unable to, unfortunately. So no, we're not able to do so. And so what do? We need nitrogen in our bodies. So what do? We take it in as food. Yeah? So we eat the plants that are able to do so, that are able to take it up. We eat the animals, we can eat the plants. So we're able to obtain all this through food. So that's part A. Part B. Now we've talked about different amino acids as well. Yeah? So we said, okay, we need to get our nitrogen in the form of foods. Now, in the foods we have proteins, and in the proteins we have amino acids. Right? We have some amino acids which we consider essential, some amino acids which we do not control, which we call non-essential. Right? What is an essential amino acid? Yeah? Okay, one you can synthesize, one you cannot synthesize. So if you cannot synthesize that amino acid, it is essential because it's essential that you do. Right? So those that you can synthesize, even if you do not have it in your diet for a while, you're still able to produce it from other amino acids or from other molecules. So in a sense, it is not so crucial. If you go a while without it, so therefore it's called non-essential. But always good to get some in your brain as well. So essential, you can synthesize from scratch, you must get it from your diet. The non-essentials, you can synthesize from scratch in your body or from other molecules. So that's your essential and non-essential. Next, some amino acids. So you have a few amino acids, cysteine, tyrosine, arginine. There are examples of amino acids. These ones are considered non-essential in adults. But strangely, if you look at children, they are listed as essential for children. Okay. Why might this be the case? So if you think about adults and children, what's the difference between them apart from size? Growth. Yeah. So it's important for children to get enough nutrients and amino acids, especially for growth. So they need to produce, they require energy, they need to produce more proteins, right, because they're growing. They need all the structural proteins, they need all the enzymes to carry out all these reactions for the growth process as well. So your children, they do need more of certain amino acids. So for us, we don't need so much because we're not doing so much of the growth compared to them. But then we're growing a lot, we're growing taller. For adults, maybe growing a bit in certain directions, hopefully not so much, but for the children, definitely growing more. So the children will need it more than the adults. So certain amino acids, not considered essential for adults, but for children, because they keep growing and they need to produce proteins